Close your eyes. Imagine the universe not as silence, but as music. 14 billion years ago, the newborn cosmos rang like a bell waves of pressure rippling through plasma, humming across infinity. And even now, that song hasn't stopped. It's stretched, faint, but still audible in the static between radio stations. These are the echoes of the Big Bang, the first song ever played.
For centuries, people wondered if the universe had a beginning. Was it eternal? Was it static?
Then, in the 1960s, two radio engineers Spensius and Wilson pointed an antenna at the sky. Instead of silence, they found a persistent hiss. At first, they blamed pigeons roosting in the dish, but when they cleaned it, the hiss remained. They had accidentally stumbled on the cosmic microwave background of fossil soundscape, carrying the memory of the universe's first 380,000 years. It wasn't silence. It was the music of creation. So what did the Big Bang actually sound like? The early universe was a hot, dense, plasmia, cosmic ocean of particles. Just like air carries sound today, this plasma carried acoustic waves. Simulations by NASA turned this into sound, a deep, resonanto rumbru, millions of octaves below human hearing. Slowed down, it becomes a haunting roar like the universe breathing. New telescopes Blunk, WMAP, the Atacama Cosmology Telescope have tuned in with precision. Each tiny variation, each ripple in the hum, encodes secrets. How fast the universe expanded. The balance between matter and radiation. Even hints about the inflationary era, when space itself ballooned faster than light. The universe wasn't silent. It was singing itself into being. Picture the universe as a resonant chamber, like a giant drum. Those sound waves rippled through plasma, leaving behind tiny density fluctuations. Billions of years later, these ripples became the scaffolding of cosmic structure, the filaments of galaxies and voids we see today. The large-scale web of the cosmos is basically frozen musica, standing wave turned into architecture. Even today, the expansion of the universe stretches those echoes! What began as deep bass notes now hums as faint microwaves, still reverberating across the sky. Every galaxy, every cluster, every void is shaped by vibrations from the first 400,000 years. The CMB isn't uniform. It's patterned with hot and cold spots, like chords layered over a melody. By analyzing them, scientists discovered the universe is 13.8 billion years old. It's made of 5% normal matter, 27% dark matter, 68% dark energy. Space is geometrically flat. These aren't guesses, they're measurements from echoes. And the instruments keep improving. Future projects like CMBS-4 and balloon missions like Spider-AIM to detect subtle polarization swirls. Those swirls could be signatures of gravitational waves from the Big Bang itself. That would be like hearing not just the song, but the drumbeat of space-time being born. Here's a thought experiment. What if the echoes had been slightly louder or softer? If the sound waves had rippled differently, galaxies might never have formed. Too smooth a universe, and matter would spread to thin no stars, no planets, no us. Too clumpy, and everything would collapse into black holes almost instantly. We exist in a sweet spot balanced by the original harmonies of creation. Every atom in your body was arranged by those vibrations. The galaxies overhead are frozen ripples from an ancient song. When we map the sky, we're not just charting stars, we're reading the musical score that made us possible. The Big Bang didn't just give us space and time, it gave us rhythm. The echoes of the Big Bang still hum today in microwaves, in galaxies, in you. So next time you hear static on a radio, remember, buried inside that hiss is the faint memory of creation's first harmony, the song of everything. Silence. The deepest silence imaginable. For centuries, we looked into the night sky and saw only a void, a black expanse, dotted with points of light. We thought the space between the stars was just that, empty space. But we were wrong. Hidden within that apparent silence is a echo, a whisper from the very beginning of everything. A fossil, frozen in time, that tells the story of our universe's violent and magnificent birth. This is not a story written in rock or starlight, but in sound. This is the story of the cosmic microwave background, the echo of the Big Bang itself. And if we listen very, very carefully, we can still hear its song. To understand the echo, we must go back to the source of the shout, the Big Bang. Not an explosion in space, but the explosive expansion of space itself. In the first fleeting moments, the universe was an unimaginably hot, dense soup of energy and fundamental particles. There was no light, as photons were trapped in a constant dance with electrons. Think of it like a plasma, a superheated fog. Light couldn't travel freely. It was like being in the heart of the Suna brilliant, but utterly opaque glow. For about 380,000 years, the universe expanded and cooled. And then, a pivotal moment. The temperature dropped enough for electrons to combine with protons, forming the first atoms, mostly hydrogen. This event is called recombination. And in that moment, the universe suddenly became transparent. It was the universe's first dawn. The photons, the particles of light that had been trapped for eons, were suddenly set free. They could now travel across the cosmos. That first blast of light is what we detect today as the cosmic microwave background, or CMB. It's the oldest light in the universe, seen in every direction we look. But it's more than light, because the early universe wasn't silent. It was ringing. The newborn universe wasn't a smooth, featureless soup. It had tiny fluctuations, quantum ripples from the Big Bang itself, areas that were ever so slightly denser than others. Dr. Thorne! Gravity went to work on these ripples. It tried to pull the matter in those dense regions together, but there was a counterforce: pressure. The intense heat and radiation created an outward pressure, pushing back against gravity's pull. This battle between gravity and pressure created waves. Compression, then matter would fall in, get heated up, and bounce back out, only to be pulled in again. The entire universe was pulsating. These are pressure waves, or sound waves, propagating through the primordial plasma. Dr. Petrova, it wasn't sound as we know it in air. It was sound in a medium of particles and light, moving at a significant fraction of the speed of light. The scale is incomprehensible. The wavelengths of these waves were astronomical in size, and the note they produced was incredibly deep. But then, at the moment of recombination, when the universe became transparent, the music stopped. The plasma vanished. The medium for the sound waves was gone. The waves were frozen in their tracks. Their pattern imprinted instantly onto the distribution of matter and the freed photons of the CMB. Dr. Thorne, it's like taking a photograph of a sound wave in water. The instant it flashes to ice. The wave pattern is preserved, a fossil of that moment of cosmic music. So, how do we hear this fossil? How do we translate a pattern of ancient light into a sound we can perceive? For decades, satellites like COBE, WMAP, and most recently, Planck have been mapping the CMB with incredible precision. They create a map of the sky, showing the tiny temperature variations, the hot and cold spots that correspond to those frozen sound waves. A more practical, hands-on voice, the data is a sphere of information. The variations are incredibly subtle differences of millionths of a degree, but they form a specific pattern. We can analyze this pattern and measure the dominant wavelengths of those ancient sound waves. The primary wavelength, the fundamental note of the universe, was determined by how far a sound wave could travel from the Big Bang until that distance became a standard ruler etched across the sky. Dr. Petrova, the frequency of that fundamental note is unbelievably low. If we could have heard it 13.8 billion years ago, it would have been a B, but A B flat 57 octaves below middle C, A P and no middle C is played, then it descends octave by octave. Each new note is deeper and more rumbling than the last. This continues until the notes are no longer musical tones, but felt as rhythmic, seismic pulses. It stops after about 7 octaves for practicality, but the implication continues. The human ear can't hear a note that low. Our hearing range tops out at about 20 hertz. This note was a million billion times deeper than that. So, to make it audible, Scientists and artists have had to scale it up. We take the pattern of the waves and shift the frequencies way up into the human auditory range. It's like taking a recording played incredibly slowly and speeding it up so we can hear the notes within it. We're not creating sound, we're transposing it. We're making the inaudible audible. This is the sound of the universe's fundamental note, transposed for our ears. A chord of creation! But the song didn't just give us a single note. The complex interplay of waves created a harmonic signature, a cosmic chord. And by analyzing these harmonics, cosmologists have been able to read the CMB like a cosmic recipe book. Dr. Thorne, the music tells us what the universe is made of. The precise amplitudes of the harmonics reveal the composition of the cosmos. 5% ordinary, matter the stuff of stars, planets, and us. 27% dark matter, the mysterious gravitational scaffolding, and 68% dark energy, the force causing the expansion to accelerate. The CMB is the ultimate time capsule. It tells us the age of the universe, its geometry, its fates, and its ingredients. It is the validation of the Big Bang Theory and our single most important window into the beginning of everything. Dr. Petrova, we are literally decoding the universe from its birth cry. Every time we look at that map, we are seeing the blueprint from which all structure the galaxies, the stars, the Earth, eventually formed. We are all, in a very real sense, a product of those sound waves. So, the next time you look up at a silent night sky, remember that the silence is an illusion. The cosmos is not still. It is filled with the fading echo of its own creation. We live in a universe that began with a bang and then rang like a bell. A song that set the stars in their motion and the galaxies in their spin. A song whose vibrations are written into the fabric of space itself and into the very atoms of our being. We are not just living in the universe. We are living inside its oldest, most enduring memory. We are listening to the echo of the Big Bang. We are hearing the song of creation.